Hello everyone. So today we are going to start a new video series. So this video will the whole video will cover in three part. So for today we are going to introduce just the one part here in this video. So we are going to run a two-phase flow simulation for air water. The system is air water. And in the first part we will cover the geometry and meshing, and the second part it will be cover the simulation setup, the boundary condition setup, and other things. And in the part 3 we will cover the post processing, how to see the results, how to make automatic graphs, and other things. So for part 1, without delaying, geometry, we will use the Ansys design modeler, because this is a relatively simple geometry, a vertical round pipe with a 3 meter length and 50.8 mm diameter. And for the meshing we will use the Ansys ICEM CFD. uh, because we want to use the O grade block, the unstructured meshing. So currently O grade block cannot be created in the fluent meshing. So that is the best software for the O grade block meshing. Without delaying, we are going to start the Ansys design modeler. So here you can start from the workbench. Let me start it. Well, the geometry for the two-phase flow is relatively an easy, you can say, very basic geometry. But the simulation setup and the time for the simulation, it's really difficult. So maybe this part for the geometry set creation and the meshing is not a difficult thing, but the simulation and the post processing is difficult. So here we can from the system components we can create the geometry here, and we want to use the Ansys design modeler. So if you click on, by default it will open the Ansys discovery. That software is relatively very complicated. So for this, first of all you need to convert your unit, because we are taking a relatively small diameter pipe, so we will use the unit millimeter here. Make sure you are using millimeter. Later it can be changed, but okay. So we are using the vertical upward pipe. We can use the XY plane and other. So in XY plane, in the second tab from the top menu, create and click on primitive. So we want to use a cylinder basically. So cylinder is here. By default it's taking in the ZZ component, it's the 30 mm, that is the length, and the radius is 20. Also for 50.8 mm diameter pipe, the radius will be 20.4 mm. Okay, and we want a vertical pipe, so we want the length in the y-axis. So here z-axis is 0 and in y-axis is 3 meter. So now it is created. After putting the dimensions, so you need to generate it. So here our pipe is generated from the perspective view. So here is our pipe, it's generated actually. You can see in the y-axis it's is the length and it's the 50.8 mm diameter. Our geometry is created. For after creating geometry, you need to specify the boundaries. Where is the inlet, where is the outlet, and what is the wall, where is the wall. Although you can do this thing in the Ansys ICM, but it will be difficult for doing there for the so I would recommend you can do this in the Ansys design modeler. Okay, so later you can use this geometry for creating another meshes. So for this we need to click on the faces. Okay, so that is the actually okay. So actually I want to draw a vertical upward. So for the vertical upward, my inlet will be start from the bottom and the outlet will be from the top, and yeah, so that is actually the top, it will be my outlet. Click on the faces and click here, right click and the name selection. So click apply and click on the generate. It's generated, so you can go and now rename it. It's my outlet is done. You can again click it, generated. Okay, so here is the wall. Generate. Oh, sorry. It's okay. And now where is my that is my inlet. Okay, so here you can see what is the inlet and outlet. Did you specify the right thing? You can click on the name selection, it will show you the location. Okay, so now our geometry is finished. So you can save this geometry for later editing and anything. You can click there and click on the export. Click on the export. That is right. Actually, I have already saved the geometry. You can save Ansys design modeler database AGDB file type. So this file can be accepted in the Ansys ICM, and also it can be modified later. So I'm using is test 1 for vertical upward. Okay, so now I will close the design modeler. So here you can like start Ansys ICM from there also, and you can actually start Ansys ICM separately also. If you want to start from this, you can go right click here and transfer data to new ICM CFD. Here the geometry will be automatically imported to your ICM. So you can click here and actually I'm opening Ansys ICM first time in this computer. So Ansys ICM basically is the meshing software. Although there are other meshing system components in the workbench like the Ansys, they have the TurboGrid, fluent meshing. So for the two-phase flow, the round pipe, we normally use this software. So there is another way to open the Ansys ICM. If you have already created the geometry, and you don't want to open the workbench, and you want to open the Ansys ICM directly and then import the geometry. There is another way. So this way is also good. You can say actually for this way, if you create a project, yeah, so your all file Ansys design modeler, ICM, fluent, post processing, everything will be saved in the single file. It's up to you what thing you prefer. So well, what I do is I prefer to save the separate file separately, because and later you will see that that will be the good method. So our geometry is already saved, so we don't need to save this project now. I'm going to close it. No, I don't want to save the project. Okay, go here. So for the geometry, we have created the geometry, a vertical round pipe 3 meter length in the Ansys design modeler. So next step is the meshing, Ansys ICM CFD. So as we can show, good there, ICM, yeah, it will be open. For example, if you have created your geometry in the SolidWorks or any other modeling software, so this way you can open geometry into Ansys ICM, because in the workbench then you cannot do this. Maybe you can import the geometry from there, but that is actually good way. I will show you there is another problem also what you need to do. Okay, so here click on the import model, and yeah, we need to go into the geometry section where we save the geometry. Okay, so test one vertical upward, here it is saved, apply, and now the model is imported. Okay, so either what way you do, by default when you open your model, your geometry in the ICM, it shows little bit like the edges are not clear. So for this you need to repair the geometry. Go into geometry and this the repair option. Uh, Click on the build topology. It should be 0.002 by default. You can use whatever you want, but 0.002 is fine. Okay, so now the edges are more clear here. So there to create O-grade unstructured mesh is usually there is 4 steps. The first step is for the same for all type of geometries, creating repairing the geometry, and then the next step is the actually create block. So we will create a block, 3D bonding blocks. Make sure the type initialization blocks should be the 3D bonding blocks. Add for the parts, click here and make it fluid. Although you can change in the fluent, but it's better to name it here. Okay, so click apply. So it seems like it should be the capital letter. That's fine. So the block is created, that block is outside the cylinder. We need to associate these edges actually to this cylinder curves, and like to insert this block into the cylinder inside. For this, in the fifth option, in the blocking, first we need to create a block, and then in the associate option, we will go to the second option, associate edges to the curves. So what are the edges? These are the edges actually, edges of the cube. So click on the edges, you can click with the left click. Once you done selecting all the edges, all 4 edges, click on the center mouse button of your mouse. It will select the edges are selected. Now you need to select the curves. Here you can call the select. Once you done, click on the center mouse button. Okay, so they are selected. Do this for the second also. It's just we need to do for the inlet and outlet. Same. Now they are connected. So they are selected. Actually now we need to associate for this type, and in the second row, third option, snap project versus. Okay, make sure to the option all visible here and click apply. So now your block is already there. Okay, so currently this is like we can create the meshing there, but this is not the O grade meshing. Let me show you why we need O grade meshing. For this we can also create the pre-mesh. Okay, here okay. So here you can see our mesh is created actually. Although it's a coarser mesh, but we can refine it. But here you can see near the wall, that is not the hexahedral mesh. Go in the center, everywhere is hexahedral mesh, but in the near the wall it's not. So that is actually the problem. That's why we need O grade meshing. Okay, we can uncheck his edges, and now we need to create the O grade. Go to the blocking and in split block, and go to O grade block, and in the first option click on select block. So this block we need to select, and after selecting click on your center mouse button. The block is selected, and now we want to select the faces of that block. We need to select the front, the inlet and outlet. So if you click on the wrong face, right click, it will unselect it. This face and this face. When you done, click on the center mouse button. Okay, it's done. Now click on apply. So now the O grade is selected. Okay, so if you want to create the mesh, go to the mesh pre-mesh parameters, that is in the blocking here, and go to the third option, the edge parameter. Basically in this we need to specify how many nodes should be on this one edge. Okay, so that is actually the axial distribution of the edges. So you can specify how many edges you want. It's like you want a coarser or you want a fine mesh. So currently I'm going to put the 300 mesh. So for this thing, the but the single cell height will be 10 mm, because the length of this pipe is 3000 meter mm. Okay, go there, and yeah, here I can specify the 2015. That's fine actually. Okay, that is actually the radial distribution here. And yeah, for this, if you know the transition layer, you want to specify the transition layer, the first cell height, here you can specify. So let's suppose I'm going to give this 20 cell total number of layers here. You can see here is the length of this edge. It's like the 15.2 mm. So if I give the 20 number of nodes for the single cell height, it should be it will be less than 1 mm. Okay, for the first cell height, I want to say it should be the 0.3, like 0.3 mm. Okay, and for the ratio, that is actually the growth ratio for from one cell to 2, and I put the ratio is 1.3. So here my first cell height is 0.3 mm, and the ratio is 1.3 mm. Then you can calculate what is your boundary layer thickness for this, because it's also depend on your velocity, and yeah, so you can see how many transition layers you want. Then you can specify the number of nodes and change the first cell height and growth ratio. Okay, let me apply it, and now we want to see the pre-mesh is created now. Okay, so if you see now, the mesh looks good. Here everywhere there are hexahedral meshes. Okay, there is nothing abnormality now, it will be. So by default the mesh is actually the structured mesh. For this, you first, if you are sure your mesh is fine, then now you want to export this mesh for the Fluent. You can see the mesh info, how many nodes are there. So, and also you can check the quality of the mesh. If you see the mesh quality and everything is fine, then you can export this mesh. For export them, first you need to convert this mesh into unstructured mesh. Okay, because Fluent solver accept only the that mesh. Okay, so meshing is done. Now in the output mesh, first of all select solver. We want to import this mesh into Ansys Fluent. Okay, it's done. And the right input. Okay, in the geometry section we also want to save this mesh test1. Okay, yes, test1. Save the project also. Yeah, it's now saving the mesh. Done with translation. Okay, we have done this. Okay, so now our meshing is done.